Hi guys, it's always nice to have the support from these guys over on the left. Thank you very much. So welcome to my presentation for today, which is going to be reverse engineering traditional 3D printed reefs to restore sloping reefs. So this is a project of mine that I'm very passionate about. So for those that don't know me, I am the director of TREC, the Tropical Research and Conservation Center over in Borneo in Sabah. And we've been actively doing a lot of stuff over there. As an introduction, so TREC, we've been established already since 2011. We are very active in trying to do coral restoration, which is something that is very important over on the side in Sabah, because there is historically so much fish bombing that has been going on that we need to do something to actively restore the reefs that are around here. So we are a volunteer organization, so we take divers, like there's a couple of that we have in the crowd, that come and join us to help and build artificial reefs. And I'm still waiting for the guys over there to finally come over. Oh yeah, run away, see you. Because these guys are also very important to participate in all of the projects that we are doing. So we are restoring fish-bombed reefs. I'll give a little bit more of an explanation on that later. Because the reefs that we have currently on Pom Pom, I've been diving there for the past 9 years, since 2015. And since the moment that I've been there, the same reefs that are completely decimated by blast fishing are still in exactly the same state as that they were 9 years ago. So that is a very big thing that keeps happening, that there's just so much destruction going on and it just doesn't recover. So it needs people like ourselves to trial and error and to figure out what we can do to restore these reefs around Sabah in particular. So today is going to be about 3D printing. 3D printing, first to explain what that actually is, right? So it's the action or the process of making a physical object from a 3-dimension digital model, typically by laying down many thin layers of material in succession. So it is a very futuristic kind of approach to anything that can be built nowadays. If you look at some of the structures that are here on the screen, like who would have thought 10, 20, 30 years ago that this would ever be possible to be printed out of thin air? And this is a technology that is absolutely like going to the next level of what is possible by computers and by technology and AI. So if we look at the current state of 3D printed reefs, it's a very active, innovative sphere. So there is so much going on at the moment with the 3D printing. If you see some of the things that are being built right now, they're building houses in 3 days' time, which is just mental if you think about the process that normally is taken to build like a full house as it goes. There's many big projects around the world. They have printers that are as high as this building to just print like these huge concrete blocks and structures. And there's a lot of companies that are actually actively designing this and actively participating in this. We have here in Malaysia, there's a couple of the companies that are also looking into what 3D printing and what that actually can bring for the future. And lastly, it should be really embraced. I think that 3D printing is really like the future forward, not only for artificial reefs or for reef restoration, but particularly for anything that is around. So, if this technology is so fantastic and there's so much opportunity and like chance that goes with that, why is it that there's such a big delay in it actually coming forward to big scale implementation? Like when we see that there's these reef structures that are actually being built like for artificial reefs, how is it possible that there's like this technology being so futuristic, but then yet at the same time never being implemented? So first of all, it is expensive equipment. The machineries that they use to 3D print, they start anywhere from 100,000 US, which is like 500,000 ringgit around about. And then it goes up all the way to like $1 million plus. And that's not ringgit, that's US dollars. So this is something that organizations are not able to achieve, right? Like we don't have the funding to do these kind of things. So secondly, there's so much research and development that takes place. Just to come to a conclusion of a certain type of model that we would want to print, There is so much technology that goes behind it. So people that are just simply going behind the computer, just drafting and drafting and drafting, and then that is being put into models, then that is then again recreated, redesigned, and it just continues the whole way forward. Thirdly, anyone who's worked with 3D printing in the past or in the future or like is currently working on it knows that these things are huge. Like there are structures that are being put down in Australia that weigh around about like nearly 2,500 kilos for one module. So they are being printed inside of factories. As it's being printed inside of a factory, it needs to be shipped around. So if we are thinking about communities like us, like on small islands, here in Malaysia, like we are working with someone from Australia to just get that shipped all the way over here to an island like Pom Pom. We're talking about forklifts to just get this onto trucks, get the trucks then to like the ships, get it onto the ships, from the ships all the way across the ocean. There's such a huge logistical nightmare that's involved, and then you don't even have it down into the water. Then you're just having it brought over, and then it can only be very delicately placed by like a huge crane, which on an ocean reef, it's nearly impossible to have like a location like that. Then we have, fourth of all, will it ever be financially achievable for us? When we look at conservation organizations, completely volunteer funded or having very limited amounts of funding, how will it be possible to ever utilize this amazing technique if we can't afford anything like that? Like we're talking about budgets, like for just a printer on itself, like $1 million. Like we could probably like run our project for around about 20 years. If we would look at this kind of funding. So will it ever be available or achievable for anything of the grassroots organizations? But what if we can take most of this away? What if we are looking now at what is the way, like if we can bring it down to the cost of reef? Like at the moment, to have a reef printed, like a large reef, we're looking at thousands and thousands of dollars. If we can take the cost away, would it then be available? If we are able to eliminate that it is like this massive, huge structure that we are then supposed to be bringing all the way down to like the islands, like if we can take that away and just make it small and simple, or if we can just reduce the weight. So instead of having a crane or instead of working with like huge boats that need to be supplying it, what if we can do it ourselves? And last of all, if we are looking at like having all of these complex techniques that we can then utilize, but make it basic, make it simple, make it so that everyone would be able to do all of these things. Like that would be something that then would bring it back to grassroots organizations like ourselves, like some of the amazing projects that are here, that are actively not having this kind of funding, but are needing this kind of funding or these kind of technologies to bring forward what conservation can do and what restoration can do. I'll come back to that a bit later, because before we go to the solution, we first need to talk about the problem, right? So this is Pom Pom. Pom Pom Island, this is 6 photos that you are seeing here right now. And this is all just destruction. This is not me going into like searching like, okay, where can I find a nice patch that is looking dead, that looks really nice for the photos to give a shocking effect. This is just 6 photos from anywhere on the island, because there is like nearly 0 coral that is on Pom Pom right now. So there's been historical blast fishing that has been taking place, meaning that they have been using bombs, for those who are not used by it. It's a fertilizer combined with like a detonator that they throw into the water that then creates a huge blast and destroys everything in the surrounding. So this has been happening, unfortunately, in Malaysia for years and years and years. There's a lot of action that's being taking place on it right now, but that doesn't create that the damage that it was is now not all of a sudden like gone. Like it's still there and it will remain there. So by doing that, it just takes away everything in forms of like the biodiversity and abundance. So there's no life that comes there. So because this is not recovering, we have to do something about that. So at TRAC or at so many of these other projects that are around the world, the issue that we are facing is that there is a slope. Almost all of the islands, especially in Southeast Asia, they're sloping reefs. As they are sloping reefs, the issue that comes forward is that we have an angle anywhere from 15 all the way up to about 45, 48 degrees, so it's very steep. But because there's like so much damage that comes forward, the growth is still amazing. We have so much amazing growth that happens on the island if we provide it with a stable substrate. And that is the main issue that we are facing right now. the coral has an inability to recover on its own. So there is human interference necessary to do something like this. And I'm never saying that, you know, our way is the best way or whoever's way is the best way. Like, we need to do what is possible. And unfortunately on Pom-Pom, nothing really helps in natural kind of sources. So we have to interfere, because the same reefs that I've dived for so many years, so many hundreds of times, they still look exactly the same if we are not taking any place. So the coral starts to grow on the rubble. The rubble is unstable, so that starts to grow to a certain size, then gravity starts to kick in and it starts to tumble down. And then as it tumbles down, it gets smothered by other dead coral, or there's just not enough light availability for the coral to actually grow. So it doesn't have a stable substrate. So we have to provide with a substrate. And that is what we have been doing for now many years and really trying a lot of stuff. So if we go back a little bit, about 2 years ago now, I got in contact with the guys from Reef Design Lab, which is a company based in Melbourne that are doing actively restoration, and they have what they want to do is to do active coral restoration by doing 3D printing to help bring forward and utilize this technique. So they are doing things like coastal protection. They've been bringing forward like to increase the biodiversity, to create habitats. Oyster recovery is something that they've been really big on in Port Phillip Bay in Melbourne. And these are the projects that they've really been focusing on. And what they really want and what they've always been doing is they've been using this 3D printing, but because it is so expensive and there's so much research and development that goes into place with this, that they are only actively able to do this for places like the Maldives, or they're able to do this for places that have so much money that they want to have this art installation that's installed. Because with the technique that it is right now, it looks really like an art installation. That's how I see it, at least. So all of these things that you see here is stuff that they've designed, and if you think about a natural concrete slab and compared to this, it's like next level that goes down. One of the projects that they've been doing is called MARS, which is Modular Artificial Reef Structure. And what they've done there is basically reverse engineer what we have currently. So instead of that, we are having to print these massive things inside of a lab. So we're talking about a printer that's probably like $250,000 US or whatsoever. They are reversing it. So instead of having one massive structure, they're bringing it down so that it's going to become a click and play system. Hence the name of the modular system. So they are printing it on a smaller scale that you can then assemble and assess on site. And this is a very interesting thing, because if we are now utilizing 3D printing, making smaller frames and structures, then we can actually install this on the islands. And as we met, and this is in 2022, as we met, we started to instigate the conversation like, okay, what if we can push this further? Because this is an installation that you see right here, is an installation that they've done in the Maldives, which is beautiful. And it's still to date, it's the largest artificial reef that they have put down in the world, as far as I know. But if someone, you can correct me if I'm wrong. But this has been the largest instruction that has been installed in the Maldives. But it's costing a lot of money. And the problem that is there is that there's, it's hard to get all the information and the data out. So we've decided to come together and join union and decide like, okay, how can we develop this to create that on an island like Pom-Pom, we can create a solution. Because we're talking a lot about Pom-Pom because I'm based on Pom-Pom. But if we are looking at Southeast Asia as a whole, not even only Southeast Asia, look at places like Africa, South America. Fish bombing is something that has been happening for decades all over the world. So the issues that we face is not only Pom-Pom. That is all over Southeast Asia. So we've been talking about how can we work on something that we redesign, that continuous design. They've already come up with the second structure that they did, but making it even further to make sure that we can get to a point of that we can create something. Hello? Yeah, that we can create something that we can actually use on sloping reefs. And that's when we come up with the Mars 2. So we've been talking about everything that we can provide further to enable it on places like Pom-Pom. And this is like the design of what we are going to be working with. So it is a modular system that is going to have a very low height distribution because it's going to have wave impact. We're going to have a large surface area simply because we want to have an opportunity for coral recruitment to actually take place. Then we will have a larger number of anchor points. So at the bottom where you can see, there's going to be on each side, each module, there's going to be 3 anchoring points, so a total of 16 anchoring points, because else it will still go down the slope. So what we really need is to make sure that this reef is staying stable. And then we're having grooves instead of the holes that you can see in the previous model that they've built. Because if we are having grooves, there's the installation that is having a possibility to clean it a lot more accessible. And then breaking down the concept, so what we want to achieve is that we can bring to island communities like Pompom, like Kalapuan, like Tioman, or like Langtenga, or any of the islands there that have the issue of sloping reefs, that we can get local communities to be printed, to get this done. So we have taken down all of the aspects that are in place to make it small. Like a mold is approximately 70 centimeters in height and width. So we are having, instead of making it printed on site and having like these huge printers that need to come to islands, etc., we are printing the molds. So the molds are now currently being printed, and they are now currently, as we speak, being shipped all the way over to Malaysia, so that we can use this material to have like just simple concrete, a simple concrete mixture that we're going to be having to make all these modules on the island. So this is with one like mold that we are creating, we can print up to 1,000 cement blocks. And what we want to do from this point on is we're going to be doing a testing. We're going to be doing a testing for Pompom, where we're going to be creating this. So this is how you can see what the structure is going to be looking like. So it is a plate kind of form, and this is going to be angulated on a slope, as you can see here in the green, and then it has plates at the end of it to create a larger distribution. But we want to keep it very low, because then at least the water flow and everything that goes through it will create that it is going to be a good habitat for all different types of species and coral sediment to take place. So the project that we have proposed and the project that we are going to be doing starting at the end of this year is a 3 to 5 year study where we're going to be focusing on is this 3D printed reef, and we are going to put that down onto the slope, is it going to stabilize that area there? And even if there's going to be more rubble that comes down, is it going to have enough elevation to create a stable substrate for coral to actually grow? Because we don't have an issue with recruitment. There's a lot of coral that actually grows on Pompom, but we have an issue that there's no surface area for it to grow. So that's what we're really going to be focusing on. So we're going to have 4 installations on the north, east, south and west side of the island to eliminate it. And then we have 3 structures on every site. At these structures, so this is the photo of a complete structure. It's going to have 16 of the individual blocks with the plates that are attached to it. And then we're going to have that on all the 4 different sites. And then what we are going to be looking at is 3 different approaches on what is going to be working. If it's going to be stable, like that's what we aim for, because that's what it's designed to do. So hopefully it stays like that. If not, then we're going to have another issue and we need to go back to the lab. But first of all, planting and maintenance. So we are going to be planting, and then we maintain it with the volunteers that we utilize to make sure that the coral is being looked after. The second one is we're going to be planting it. So we put it down, plant the coral on it, but then we're not going to do any maintenance on it. So we just leave it as it is and see what the best growth is going to be. And the third one is going to be no planting. So we just put the structures down and leave it for what it is. And then we just see after 3 to 5 years what the effect is going to be. And then fourth of all, we've got the test site. So we're going to be looking at, okay, when we are having these structures that we put down, what is the compare for the fish abundance and the biodiversity and increasement of like coral species, recruitment, how is that going to be showing down? So that's like the 4 different methods that we are going to be looking at. If we are looking at the potential outcomes, and this is where I find this is going to be very interesting. So if we are going to be planting it and we are placing a new substrate on it, and then we are going to have like the first result is going to be after 5 years, the coral planted and maintained is so much higher than the other 2 methods. which would be fantastic. Because if we are having that, we can justify the labor that we put into place to maintain these corals and the planting that we do, to see that this is going to have the best outcome for all of the reefs that are going to be around of it. So that's going to be a very exciting one, because then we are going to have the opportunity to give it to local divers like yourselves or anyone else, to take community groups involved, and to make sure that when this is being put down, that we can justify why this is important and why this is necessity, giving it an opportunity as well to give it to funders that we have actively involvement and proving scientifically that this is the best method that we can do. The only negative that we have is it's going to be a limitation in terms of what we can actually do, because if we don't need to have the active maintenance of the diving, of the structures, we are having a lower risk, we are having a lower area that we can actually cover, because we need a lot of people that need to be involved. So it would be fantastic if this is the best outcome, because we can also get a lot of local communities involved, but it would not be the best in terms of the long term. The second one, if we are going to be planting the reefs, planting coral on it, but then after that we are not going to do anything with it, and that comes out to be almost the same as the labor intensive one, or at least a lot better than the ones that we have not planted on, that would be fantastic. Because if we are able to just put it down, plant it, and then we can take our hands off, then we have the scientific data to back up why this is such a good method to restore sloping reefs around, not only Pompom, but potentially even Southeast Asia. So we can then significantly reduce the labor, so we can get it to dive centers, or we can get it to community groups, or even island groups that we can just get employed by funding, because we can show we just need to make them, which anyone can do that can make cement. We train them how to do it, and then they can just place the installations, and as soon as the installation has been placed, plant it, take our hands off of it, and then we would have potentially the best results of that all. So then we can have a production that goes really quite far, because we can have really at that point having funders and then training, what Reef Check is doing, working with community groups, that we can train these people on how to actively participate and make these reefs and do the installation of it and all. So that would be an ideal situation in that sense. A big positive for that as well is that we can mass implement it if we have the scientific data to prove it, and then we can restore a lot of these reefs that have been so damaged for over decades and decades of abuse. So then the last outcome, and this would be almost the most ideal outcome that we would have, we deploy the artificial reefs. We are not planting it, we are just leaving it for what it is. If this would be the best outcome that we are going to be able to achieve, how is that going to move forward? Is that we have the scientific data to prove that after 3 years or 5 years time, it is going to have almost the same effect of having no further involvement, no planting, no maintenance, and that's going to be the best of involvement that's going to be there. Then we can really train as many groups as possible and get so many divers involved with just the simple method of this is how it's been done, this is how it's trained. We've got the scientific data to prove and to have the evidence that this works out really well, and then we can really restore massive amounts of reefs. So I'm really excited to have 3D printing, a technique that I never thought that was going to be ever available to anyone like Trek or for any of our organizations, and to really have this trial on it and to work on that and to really see what the future will hold. So to recap it slightly, when we are talking about 3D printing reef, I think personally that we are really on the verge of a real breakthrough. Anything that we are able to do right now, it's only the start of it. If we see where 3D printing was about 10 years ago and where it is right now, it is a huge, huge, huge upswing. There's so much possible, and especially if we are able to bring it down to a perspective that we can make small reefs, that we print the mold, and once the mold is printed, anyone can do it that can mix cement in the right mixtures. So it's very limited amounts of training that are necessity to actually implement this on a large potential scale. And that's something that I think is really, really exciting. When we look at the research, more research needs to be done. Like this is going to be one of the first installations that is around the world that we're actually going to be testing on. There's 5 sites in total in the whole of the world that are testing with this currently and are doing research on it. But we are the only ones that are going to be trialing all of this based on sloping reefs. And if we think about it, if you're a diver and you've been diving around, how often are you diving on a sloping reef? How often are you going to a place and you look like, oh yeah, it's got a slight slope down. Everyone has seen the destruction. Everyone has seen, like, especially if there would be like the coral bleaching that happens in mass effects and it all breaks down and it all turns to rubble. We need to have like a quick response to it. So if we have the scientific data to back it up that this would be potentially like the future of coral restoration by having 3D printed implemented into Malaysian reefs or wherever in the world, like that is really exciting, and that's really what for me is an exciting time ahead if we can see how big can this go. So it'll be very interesting. But you know, we have to still look at financially being able to put this forward, because if we are able to bring this forward, the best idea would have local communities to be completely trained on this. If we have the local communities that are able to take part of this and are able to just continue with all of this for ages, like then we can really make an impact. And that is something that I find exciting, right? That we have a small kind of idea that could lead to like a relatively big impact as we go. And that's how it should be with conservation. But we first need the science and the data to back it up. So we first need to get this project properly done and properly run around, and then we can restore a lot of coral, hopefully, around the world. And lastly, yeah, the potentials are endless. We can go as far as you want to go. Like 3D printed, if you think about it now, it's almost impossible. There's just, the future is there, and I think it's very exciting. Final shout out, I really want to have a special shout out to the Reef Design Lab, the guys in Melbourne. They're doing a fantastic job. Like we spoke about it, we had this idea, and they just ran with it. They just designed it to a perspective that is now going to be looking at that we can actually make a good impression and potentially like a groundbreaking thing for restoration. At least, you know, one can only hope, right? That's how it does. For anyone that wants more information, you can on Reef Design Lab or for Trek Borneo, or potentially myself, Robin Philippo as well. Feel free to reach out, send me a message if you want to get involved with Trek, if you want to get involved with any of the projects, or if you want to be more involved with like the 3D printing that we do, which is a very exciting time ahead. Very much want to see if you guys join, and then thank you very much for this. I'm going to open up the stage just for some questions. Is anyone that has questions? Doesn't look like it. No one? Okay, then I want to utilize these last couple of minutes before the lucky draw that's going to take place. It's a little bit cheeky because it's got nothing to do with 3D printing. But because there's a lot of people here right now that are here for the lucky draw, and I applaud you for the lucky draw. I hope that you win. I hope that you win the trip to the Maldives. That's going to be fantastic. But these are all the marine conservation centers that we have in Malaysia. A lot of you guys are based here in KL. There's all these projects that are all over Malaysia, and they need help. They need volunteers to do the work. Like we as Trek, for example, we would not be able to do the work without people that are joining in as volunteers. And I've got all of these projects that are here. So we've got One Ocean Empire, which is Monica that's here just on the booth right there. We've got Reef Check Malaysia, Alvin that's sitting in the crowd, but we've got the stage. Coral Cool Conservation, unfortunately they're not here, but they're based up in where are they? Langtenga? Alvin, where is Coral Cool again? Langtenga, right? Yeah. So in Langtenga, we got Bubbles Resort, Perhentian Turtle Project, and Perhentian Marine Research Station. They're over on the left side as well. Tenga Island Conservation, also based on the left side. You can find Iman and you can ask him all about it. Gaia 1 Restoration, who are all the way at the back in the corner just behind there. And then last of all, like Trek, our own organization, we are based in Sabah, and we are using like this space as well to do a lot of restoration that takes place. And we really need volunteers, and I really want to applaud all of you guys. Please, please, please get involved, because for any of us, we are not able to do the work that we do without having volunteers. None of us is funded by the government. We are doing this all based on the foundations and the donations that we get from people like yourselves, and this is the most vital part. And I really want to ask you guys, all of the, underneath you can see all the handles. Please follow them on Instagram. Please go to their website. Please try and figure out if you can join them in any formal way, whether it's in a monetary donation, or you want to volunteer with them, or just give them a follow on Instagram. And I'm going to leave it on here as well, because I want as many people as possible to just go on Instagram and just follow all of these guys, because they do amazing work and they need the help very much. Thank you very much, and I want you to enjoy the lucky draw.